Associate Professor in Department of Chemistry, PSN College of Engineering and Technology. Now we are discuss about corrosion and corrosion control. First of all, introduction for the corrosion. Corrosion is an undesirable process. Undesirable means it's not like that process. Due to the corrosion, there is limitations of progress in many areas. Corrosion is unlimited. Metals and alloys are used as fabrication or construction metals in engineering. If the metals or alloy structures are not properly maintained, they deteriorate slowly by the action of atmospheric gases, moisture and other chemicals. This phenomenon of destruction of metals and alloys is known as corrosion. The corrosion is undesirable process. Due to the presence of atmospheric gases and moisture and other chemicals, at that time the metals are corroded. Then corrosion of the metal is defined as the spontaneous destruction of metals in the course of their chemical, electrochemical or biochemical interactions with the environment. Thus it is exactly the reverse of extraction of metals from ores. The example, rusting of iron. A layer of reddish scale and power of oxide Fe3O4 is formed on the surface of iron metals. A green film of basic carbonates CuCO3 plus CuOH twice is formed on the surface of copper when it is exposed to moist of air containing carbon dioxide. This is the metal of corroded metal. Then causes of corrosion. There are two types of causes of corrosion. The first one is native state, the second one is combined state. Now we can see the native state. The metals exist as such in the earth crust, then the metals are present in the native state. The native state means a free or uncombined state. These metals are non-reactive in nature. They are noble metals which have very good corrosion resistance. Then say the example of noble metals are Au, Pt and Ag, etc. Then second one is, we can see the second one, the combined state. Except noble metals. Noble metals are inert metals. The noble metals does not react with any other chemicals compounds. Then all the other metals are highly reactive in nature, which undergoes a reaction with their environment to form stable compounds called ores and minerals. This is the combined state of metals. Example, Fe2O3 and zinc oxide, PbS and CaCO3, etc. Then classification of theories of corrosion. Then based on the environment, corrosion is classified into two types. Then dry or chemical corrosion. Second one is wet or electrochemical corrosion. Then let us see, then dry or chemical corrosion. This type of corrosion is due to the direct chemical attack of metal surface by the atmospheric gases. That like the gases of oxygen, halogens, hydrogen sulfide, sulfur dioxide and nitrogen or anhydrous inorganic liquid, etc. Then the chemical corrosion is defined as the direct chemical attack of metal by the atmospheric gases present in the environment. Then example, silver metals undergo chemical corrosion by the atmospheric hydrogen sulfide gas. Then second example is iron metal undergo chemical corrosion by HCl gas. Then types of dry or chemical corrosion. Corrosion by oxygen or oxidation corrosion, the first one. Second, corrosion by hydrogen. Third one, liquid metal corrosion. Then corrosion by oxygen or oxidation corrosion. Then oxidation corrosion is brought about by the direct attack of oxygen at low or high temperature on the metal surface in the absence of moisture. Then alkali metals, say some examples of alkali metals are lithium, sodium, potassium, etc. Then and alkaline earth metals, magnesium, calcium, tin, etc. are rapidly oxidized at low temperature. At high temperature, almost all the metals except gold, silver and platinum are oxidized. The reactions of oxidation and corrosion are as follows. Then let us see the mechanism of corrosion by oxygen for oxidation corrosion. Then oxidation takes place at the surface of the metal, forming metal ions Me2 plus. The first the corroded at the surface of the metals. The metal is denoted M. Use M2 plus a liberation of 2 electrons. That is oxidation reaction. Then oxygen is converted into oxide ion due to the transfer of electron from metals. That is oxide ion. The absorption of electrons to give oxide converted into oxide ion O2 minus due to the transfer of electron from metal. The overall reaction is oxide ion react with the metal ion to form metal oxide film. The metal plus oxygen to give N plus O2 minus. The nature of the oxide formed plays an important part in the oxidation corrosion process. And the metal is reactive with oxygen to give metal oxide, that is a corrosion product. When the oxidation starts, a thin layer of oxide is formed on the metal surface and the nature of the film decided the further action. If the film is maybe stable layer, means a stable layer is fine grained in structure and can get adhere tightly to the parent metal surface. Hence, such layer can be of imperviation nature, that is which cut off penetrations of attracting oxygen to the underlying metal. Such a film behave as a protective coating in nature, thereby shielding of the metal surface. The oxide film on aluminium, tin, lead, copper and platinum etc. are stable, tightly adhering and impervious in nature. Maybe the film is formed in unstable oxide layer, means this is formed on the surface of noble metals such as gold, silver, platinum. As the metal state is more stable than oxide, it decomposes back into the metal and oxygen. Hence, the oxidation corrosion is not possible with noble metals. Maybe the film is formed the volatile oxide layer. The oxide layer film volatile as soon as it is formed. Hence, the always a fresh metal surface is available for further attack. This causes continuous corrosion. MoO3 is volatile in nature. Then maybe film is formed in porous layer, means the layer having the pores or cracks. In such a case, the atmospheric oxygen have access to the underlying surface of metal. Though the pores and cracks of the layer, thereby the corrosion continues unobstructed till the entire metal is completely converted in its oxide. Then this is the picture of oxidation reaction and reduction reaction. Oxidation reaction means the absorption of electrons. Then reduction reaction means that is liberation of electrons. The corrosion by other gases by hydrogen. And then first let us see hydrogen embrittlement. And the definition of hydrogen embrittlement means loss in ductility of the metal in the presence of hydrogen is known as hydrogen embrittlement. And then let us see the mechanism of hydrogen embrittlement. This type of corrosion occurs when a metal is exposed to hydrogen environment. Ion liberate atomic hydrogen with hydrogen sulfate in the following way. The first one is hydrogen sulfate react with ion to give Fe plus to hydrogen. The hydrogen diffuses into the metal matrix in the atomic form and get collected in the voids present inside the metal. Then further diffusions of atomic hydrogen make then combine with each other to form hydrogen ions. The collection of these gases in the voids develop very high pressure, causing cracking and blistering of the metal. Then decarburization. The presence of carbon in steel gives a sufficient strength to it, but when the steel is exposed to hydrogen environment at high temperature, atomic hydrogen is formed. Then atomic hydrogen react with the carbon of the steel, the produced methane gas. Then let us see the equations. The first hydrogen molecule is converted into atomic hydrogen. Then that atomic hydrogen is react with the carbon, or we get the methane gas. Hence the carbon content in steel is decreases. The process of decrease in carbon content in steel is known as decarburization. Decrease in carbon content, that's the main point of this one, the decarburization. The collector of methane gases voids of steel develop high pressure, which cause cracking. The steel loses its strength. Then next one is liquid metal corrosion. This is due to chemical action of falling liquid metal at high temperatures on solid metal or alloy. Such corrosion occur in devices used for nuclear power. The corrosion reaction involves either dissolution of solid metal by liquid metal or internal penetration of the liquid metal into the solid metal. Both these modes of corrosion causes weakening of the solid metal. And then second one is wet corrosion or electrochemical corrosion. Electrochemical corrosion involves the formation of anodic cathodic area at the parts is contact with each other. The presence of a conducting medium, the corrosion of anodic areas only, formation of corrosion product somewhere between anodic and cathodic areas. This involves the flow of electron current between the anodic and cathodic areas. Then anodic area, oxidation reaction takes place. That means the liberation of free electron. So anodic metal is destroyed by either dissolving or assuming combined states such as oxide, etc. Hence, corrosion always occurs at anodic areas. The metal ion plus liberation of electrons. Then cathodic area, the reduction reaction takes place, the gain of electrons. Usually cathode reactions do not affect the cathode since most metals cannot be further reduced. So at cathodic part dissolved constituents in the conducting medium aspect the electron to form some ions like OH minus and O2 minus. Cathodic reaction consumes electron with either by evaporating of hydrogen or absorption of oxygen depending on the nature of the corrosive environment. Then hydrogen evaluation type. All metals above hydrogen in the electrochemical series have a tendency to get dissolved in acidic solution. With simultaneous evaluation of hydrogen, it occurs in acidic environment. Consider the example of ion. The first one, anodic reaction. Ion is converted into Fe2 plus liberation of 2 electrons. Then these electrons flow through the metal from anode to cathode, where H plus ions of acidic solution are eliminated as hydrogen gas. Let us see the equation 2 H plus acceptance of 2 electrons give hydrogen gas. Then overall reaction is Fe plus 2H plus gives Fe2 plus hydrogen gas. And the 2 electrons and 2 electrons are cancelled. See the picture. Then oxygen absorption type. The rusting of ion in natural aqueous solution of electrolyte. What are the electrolytes like in NaCl solution? The presence of atmospheric oxygen is a common example of this type of corrosion. The surface of ion is usually coated with a thin film of oxide. However, if the iron oxide film develops some cracks, anodic areas are created on the surface, while the well metal part acts as the cathode. At anode, metal dissolves as ferrous ion with the liberation of electrons, that is oxidation reaction. At the cathode, the liberation of electrons is intercepted by the dissolved oxygen, the formation of 2OH minus ion. The Fe2 plus ion and OH minus ion diffuse when they meet. Ferrous hydroxide is precipitated. If enough oxygen is present, ferrous hydroxide is easily oxidized to ferric hydroxide. Then yellow rust. FeOH twice plus react with oxygen plus water molecule to give FeOH thrice, that is yellow rust. If the supply of oxygen is limited, the corrosion product may be even black and anhydrous magnetite Fe3O4. See the diagram. Anodic reactions and cathodic reactions. acceptance of electrons, and cathode reaction is the formation of OH minus ion. The anodic part is corroded. Types of electrochemical corrosion. The electrochemical corrosion is classified into following two types. There are two types of galvanic corrosion and differential aeration or concentration cell corrosion. First, let us see the galvanic corrosion. When two dissimilar metals, the zinc and copper, are electrically connected and exposed to an electrolyte, the metal high-risk electrochemical series undergo corrosion. In this process, the more active metals, electrode potential acts as an anode, while the less active metal, that is less negative electrode potential, acts as the cathode. The above example, zinc is a higher electrochemical series, forms that is act as the anode and is attacked and get dissolved, whereas copper, that is lower electrochemical series, are more act as the cathode. Here is a diagram. Then anodic and cathodic part is connected. The current flow of ionic conductance. Mechanism. In acidic solution, the corrosion occurs by the hydrogen evaporation process, while in a natural or slightly alkaline solution, oxygen absorption occurs. The electron current flows from the anode metal zinc to the cathode metal and copper. Use Zn2++ 2 electron, that is oxidation reaction. Thus it is evident that the corrosion occurs at the anode metal, while the cathodic part is protected from attack. Example, steel screw in a brass marine hardware, lead antimony holder around copper wires, a steel propeller shaft is bronze bearing, steel pipe connected to copper running. This is the picture. Then this is due to the electrochemical attack on the metal surface exposed to the electrolyte of varying concentration or varying aeration. It occurs when one part of the metal is exposed to a different air concentration from the other part. This is cause a difference in potential between differentially aerated. It has been found experimentally the poor oxidative parts are anodic. The example, the metal part is immersed in water, conductor liquid. Then waterline corrosion, the metal part partially buried in soil. Then this is the explanation. If a metal is partially immersed in a conducting solution, the metal part above the solution is more aerated and becomes that part is anodic. The metal part inside the solution is less aerated, thus becomes anodic and suffer the corrosion. To see the diagram. And then Zn2, then that metal is dipped into the water. That water means that is solvent, NaCl solution. Then the NaCl solution is dipped into the metal. The metal is it can be easily corroded. What's the reason is the less aerated part is dipped metal. Then at the anode, corrosion occurs less aerated. Metal use metal ion plus liberation of electron. At the cathode, OH minus ions are produced. That is more aerated part. Oxygen react with water and acceptance of 2 electron. The formation of 2 OH minus. The example part is type of corrosion are crevice corrosion, pipeline corrosion, corrosion on wire fence, pitting or localized corrosion. Let us see now the pitting corrosion. Pitting is a localized attack and which result in the formation of hole around the metal is relatively unattacked. See the diagram. This is the metal surface. Then one part of the metal surface is affected, that create the pit. The mechanism of the corrosion involves setting up of different aerations and concentration cell. The metal area covered by a drop of water, dust, sand, scale, etc. It is the aerations or concentration cell. Pitting corrosion is explained when considering drop of water or brine solution. Brine solution means the aqueous solution of NaCl on the metal surface, especially the ion surface. The area covered by the drop of the salt solution has less oxygen and acts as an anode. The area suffer corrosion. The uncovered area acts as the cathode due to the high oxygen content. It has been found that the rate of corrosion will be more when the area of cathode is larger and the area of anode is smaller. Hence, there is more material around the small anodic area, result in the formation of hole pit. See the picture. This is the one of the ionic surface metal. And then formation of pit means that one part of the surface is covered in the moisture or some rain solution. That part acts as an anodic part. It can be easily corroded. Due to the reason is less aerated area. Then anodic reaction. Ion is oxidized to Fe2 plus and release electrons. Fe2 plus 2 electron. At cathode, the oxygen is converted to hydroxide ion, OH, the formation of OH minus ion. Then see the net reaction. Fe plus 2 OH minus gives Fe OH twice. Then crevice corrosion. If a crevice or a crack formation of narrow opening between the metallic and non-metallic material in its contact with a liquid, the crevice becomes anodic region and undergoes corrosion. Hence, oxygen supply to the crevice is less, exposed area and high oxygen supply and acts as cathode. Bolt, nuts, rivets, joints and example of this type of corrosion. See the picture. Then next one is pipeline corrosion. The buried pipeline or cables and passing from one type of soil, that is clay, less aerated, to another soil, sand, more aerated, may get corroded due to the differential aeration. Compared to clay and soil, the soil is a more aerated part. Then corrosion in wire fence. The wire fence is which the areas where the wires across anodic are less aerated than the rest of the fence. Hence, the corrosions take place at the wire crossing. The corrosion occurring under the metal and lead pipeline passing through the clay to there are other example. See the picture. The crossing the wire fence, that part is less aerated, can be easily corroded that part. Then corrosion control. Choice of metals and alloys. The first choice is to use noble metals and such as gold and platinum. The noble metals are not reactive with any other chemical compounds or any atmospheric changes. So we can first choose the noble metals. They are most resist to corrosion as they are precious. They cannot be used for general purpose. The next choice is to use purest possible metal, but in many cases it is not possible to produce a metal of high chemical purity. Hence, even a trace amount of impurity leads to corrosion. The next choice is the use of corrosion resistant alloys. Several corrosion resistant alloys have been developed for specific purposes and environment. For example, stainless steel containing chromium produced the coherent oxide film will protect the steel from further attack. Cupro-nickel, that is cupro-nickel means 70% copper and 30% nickel. This composition is combined to cupro-nickel. The alloy are now used for condenser tubes and for bulk tires used is fractionation column in oil refineries. The highly stressed pneumatic alloys, that is the combination of nickel, chromium and molybdenum alloy, used is a gas turbine and very resist to hot gases. Then the proper designing. The proper geometrical design play a vital role in the control of corrosion of equipments and structures. The general guidelines of the design of metals and components to control corrosion are the following. Then use always simple design and structure. We can make the machines means design the simple structure. The design must avoid more complicated shape, have more angles, edges and corners. Avoid the content of dissimilar metals as they may lead to galvanic type corrosion. To overcome this, insulation can be used. When two dissimilar metals are to be in contact, the anodic area must be as large as possible and the cathodic area should be as small as possible. As far as possible, crevices should be avoided between adjacent parts of a structure. Bolt and rivets should be replaced by proper welding. Metal washes should be replaced by rubber or plastic washes, or they do not absorb water, they also act as insulation. Corrosion in pipeline can be prevented by using smooth bends. Heat treatment like annealing, minimizing the stress corrosion. Good design of water storage container is one form which water can be drained and clean easily. Such a design avoid accumulation of like etc. Here on is the poor design. More crevices and bolt joints and bends. Here on is a good design. Then see poor design. Poor design, that is best design. The smooth bend. We can make this smooth bend. Once again I repeat. Types of corrosion: corrosion by oxygen and corrosion by hydrogen, liquid metal corrosion. There is oxidation corrosion. Then oxidation means the liberation of electrons. Then formation of metal ions. Then the formation of metal ions. Then acceptance of electrons due to the oxygen ion is formed. Then metal plus oxygen gives metal oxide film is formed. That is the corrosion product. Maybe if the film is stable means that is fine grain structure get adhered tightly to the parent metal surface. That is impervious in nature. The unstable oxide layer means then only the form in the noble metals. Noble metals gold, silver and platinum. The metallic state is more stable than oxide. It decomposes back to the metal and oxygen. Then oxidation corrosion is not possible for noble metals. Maybe the film is formed is volatile oxide layer means the always pressed metal surface is available for further attack. And this causes continuous corrosion. MoO3 is volatile in nature. Maybe formed in the film is porous layer. Then layer have the porous and crack. In such cases, atmospheric oxygen have access to underlying surface of the metal. Then pores and cracks of the layer, thereby the corrosion continues. This is the picture. Then corrosion by other gases, the hydrogen embrittlement. Hydrogen embrittlement means the less in ductility of the metal in the presence of hydrogen. That is a mechanism. Ion react with the hydrogen sulfate to give ion sulfate plus 2H. Then the hydrogen atom is combined to give hydrogen gas. That hydrogen gas is collect the voids and develop very high pressure, then causes cracking and blistering of the metal. Then decarburization means the presence of carbon steel gives sufficient strength, but the carbon content is reduced at that time. That is we are call it as decarburization. The hydrogen molecule is converted into hydrogen atom. The atomic hydrogen react with the carbon of steel produced methane gas. The carbon content of the steel is decreased. The process in decrease in carbon content steel, it is known as decarburization. The collection of methane gas is voids of the steel develop high pressure which causes cracking. And then liquid metal corrosion. The corrosion involves dissolution of the solid metal by liquid metal, internal penetration of the liquid metal into the solid metal. Both these modes of the corrosion cause weakening of the solid metal. Then wet or electrochemical corrosion. The electrochemical corrosion involves the formation of anodic area. Specifically, the corrosion is occurring in anodic area. The presence of the conducting medium. Corrosion of anodic areas only. The formation of corrosion products somewhere between anodic and cathodic area. This involves flow of electrons current between anodic and cathodic areas. The metal is converted into metal ion, the liberation of electron. Then cathodic reaction consumes electron either by evaluation of hydrogen, absorption of oxygen. Hydrogen evaluation type. Then anodic reaction, Fe use Fe2++ 2 electron. Then cathodic reaction 2H++ 2 electron to hydrogen gas. The overall reaction is Fe plus 2H plus Fe2++ hydrogen. They cancel 2 electrons. See the picture. Oxygen absorption type. The rusting of ionic neutral aqueous solution, the electrolyte like sodium chloride, the presence of atmospheric oxygen, common example of this type of corrosion. Fe plus Fe2++ 2 electron. Oxygen react with water, acceptance of 2 electron, the formation of 2 OH minus. Then Fe2++ 2 OH minus is FeOH twice. Then finally the rust, yellow rust is formed. Then types of electrochemical corrosion, there are 2 types, galvanic corrosion and different aeration corrosion. In galvanic corrosion, 2 dissimilar metal is connected with each other. More negative electropotential acts as an anode, less negative electropotential is act as the cathode. Here is zinc acts as the anode and copper acts as the cathode. Then differential aeration corrosion, the metal is dipped into sodium chloride solution. The dipped part of the metal is less aerated, that is it can be easily corroded. That part is act as an anode. Then anodic reaction, the liberation of electrons, the cathode acceptance of electron. Another examples of less aerated part is crivey corrosion and pipeline corrosion, the corrosion of wire fence and pitting corrosion. The pitting corrosion means that is the ion surface. Then one part of is affected, covered in the brine solution or any other moisture. That part is act as an anode, that is less aerated part, it can be easily corroded. That's a reaction, anodic reaction and cathodic reaction. Then crevasse corrosion. It is crevasse between the metallic and non-metallic materials in contact with the liquid. The crevasse becomes anodic region and undergoes corrosion. Hence oxygen supply to the crevasse is less, exposed area has high oxygen supply, that's the acts as an cathode. The example, bolt, nuts, rivets and joints, that's the example of type of corrosion. Then pipeline corrosion, the pipelines are buried under the clay or soil. The clay is less aerated part. Then soil is more aerated part. So it can be easily corroded part is less aerated part. That's just the anodic part. Corrosion in wire fence. The wire fence is one in which the area wires cross and less aerated the rest of the fence. Here the corrosion takes place at wire crossing. The corrosion occurs under the metal lead pipeline passing clay to get or is other example. Just see the diagram. The corrosion control, the first one, choice of the material. We can choose the best metals. Then proper design in the machines. Here the poor design, that's poor design, bolt joining, crevices and bends are more. Then good design. Then poor design and best